Good morning, students. Students, today we will discuss a topic atmospheric refraction and formation of rainbow. इस टॉपिक में हम पढ़ेंगे कि कैसे एक लाइट जो एटमॉस्फेयर से बाहर से एटमॉस्फेयर में होती हुई हम तक पहुंचती है, उसे क्या क्या डेविएशंस, क्या क्या वेरिएशंस सहन करने पड़ते हैं, और दूसरा कि आसमान में इंद्रधनुष कैसे बनता है. So for this, today's topic goes like this. First we will recapitulate what we have studied related to the topic. Then we will study atmospheric refraction, then formation of rainbow. Then we will assess what we have studied today in the last summary, and we will wind up with homework. So here are new terms for you. First is atmosphere. Yes, we all are aware what is atmosphere. It is the envelope of gases around us. Now what is atmospheric refraction? The refraction of the light by the atmosphere is known as atmospheric refraction. Rainbow. The beautiful pattern of colors, 7 colors in the sky after rain is known as rainbow. Rare medium, where the particles of matter are far from each other and the velocity of light is faster in this medium as compared to another medium. The last new term is denser medium. A medium where the particles of matter are close to each other, and in this velocity of light is less as compared to another medium. That medium is known as denser medium. Now coming to today's topic. What is related to today's topic? First is spectrum. The band of 7 colors obtained on a screen is known as spectrum. We know that white light comprises of 7 colors. Yes, here is the figure, and you can recapitulate from this figure that red, orange, yellow, green, blue, indigo and violet are the 7 colors of which white light is formed of, and white light is also known as sunlight. Dispersion. Splitting of white light through prism is known as dispersion. Monochromatic light. The light of single wavelength, that is the single color light, is known as monochromatic light. Dispersion of light. When white light of sun is allowed to fall on the prism, it splits into 7 colors. This phenomena of splitting of light is called dispersion of light. Now here is atmospheric refraction for you. Now here is a word atmosphere in this atmospheric refraction. Atmosphere comprises of few layers. First layer is troposphere, which is roughly approximately up to height of 20 km. Then stratosphere layer of atmosphere, which is from 20 km to 50 km above the Earth's surface. Then is mesosphere, whose height is from 50 km to 85 km. Then thermosphere, from 85 km onwards and up to 690 km approx. And in the last there is exosphere, which is from 690 km to 1000 km above the Earth's surface. We all know that as we move up, the density of the gases decreases. Earth's gravity decrease as we move away from the Earth's surface. हम जितनी हाइट पे जाएंगे ग्रेविटी उतनी कम होती जाएगी, और जैसे ही हम स्पेस में पहुंचेंगे, स्पेस में अर्थ की कोई पुल नहीं होता, अर्थ की कोई ग्रेविटी नहीं होती, इसीलिए ऑब्जेक्ट्स फ्लोट करते हैं. वहाँ किसी भी ऑब्जेक्ट की ग्रेविटी नहीं है, वेटलेसनेस फील होती है. तो यहाँ पे एटमॉस्फेयर की लेयर्स, डिफरेंट लेयर्स का क्या रोल है? जो अर्थ के सबसे नज़दीक लेयर है ट्रोपोस्फियर, उसके अंदर बहुत सारे डस्ट पार्टिकल्स होंगे, हैवी पार्टिकल्स होंगे, तो वो सबसे ज़्यादा डेंस होगी। उससे कम डेंस होगी स्ट्रेटोस्फियर, उससे भी कम डेंस होगी मेसोस्फियर, थर्मोस्फियर मेसोस्फियर से भी कम डेंसिटी की होगी, और एक्सोस्फियर की डेंसिटी इन सभी लेयर्स में सबसे कम होगी। So, we all know that when a light enters from a medium to another medium whose density varies, it deflects from its path. As you can see in the figure, a ray of light which is entering from a rare medium to a denser medium. Rare medium is shown by white and denser medium by medium 1. Then this ray of light deflects towards normal. It changes its path. And when it enters from medium 1 to medium 2, and medium 2 is rare as compared to medium 1, then again it deflects its path and it moves away from the normal. And when it enters from medium to another medium, again the white area shows it is rare as compared to medium 2. Medium 2 is dense as compared to white area, so it again further bends away from the normal. So in these 3 points where refraction takes place, the course of light, the path of light changes. This is refraction, and we all know that all the different layers of atmosphere are having different densities. So the light entering through the atmosphere reaching to the earth will also show this phenomena. Let us see. Here you can see earth and a object. A object which is luminous object producing some light, and a light ray which enters earth atmosphere from this source of light changes its path when it enters from one atmospheric layer to another atmospheric layer. When light goes from one medium to another medium having different optical densities, then refraction of light rays, or you may say bending of light rays, takes place. All the air in the atmosphere is not at same temperature. Some of the air layers of atmosphere are cold, whereas other air layers of atmosphere are comparatively warm. The cooler air layers of the atmosphere behave as optically dense medium for light rays, and whereas warm air layers or hotter air layers of atmosphere behaves as optically rare medium of light rays. So in the same atmosphere we have air layers having different optical densities, and when light rays pass through the atmosphere having air layers of different optical densities, the refraction of light takes place. If we look at object through the hot air over a fire, the object appears to be moving slightly. This is a journal example you have seen in your daily life. The air just above the fire becomes hot. Then hot air is optically rare, but the cold air further up and around is optically denser. So when we see the objects of the light coming from them through hot air and cold air layers having different optical densities, then refraction of light takes place randomly, due to which the objects appear to be moving slightly. Under normal circumstances, the air in the upper atmosphere is optically rare, and as we come down, the air in the lower atmosphere is optically denser. Hence, the ray of light bends, and it bends towards normal. Some of the optically phenomena in nature which occurs due to atmospheric refraction of light, examples are twinkling of stars. Second, the stars seems higher than they actually appear, as you can see in this figure. Advanced sunrise and delay sunset. जी हाँ, सूरज कुछ देर पहले हमें दिखाई देता है उगने से और कुछ देर बाद तक हमें दिखाई देता है छुपने के बाद, जिस वजह से दिन थोड़ा सा बड़ा हो जाता है। और ये सभी एटमॉस्फेरिक रिफ्रैक्शन फिनोमिना की वजह से होते हैं, क्योंकि लाइट बेंड करती है जब भी वो एटमॉस्फेयर की एक लेयर से दूसरी लेयर में ट्रेवल करती है। So I hope atmospheric refraction is clear to you. Now coming to formation of rainbow. We all have studied prism in last class. When white light of sun falls on tiny droplets, these tiny droplets of rain behaves as prism. Then these small prism splits this white light of sun into 7 colors. After facing refraction, these 7 colors travel inside the drop and then suffer internal reflection. As you can see in this figure, white light, sunlight is entering into the raindrop. Here raindrop is considered as a round circular shape. After the refraction, this white light splits into 7 colors. As we know that optically denser medium, optically different medium, light travels with different velocity, and light comprises of 7 colors: violet to red, Vibgyor. Red is minimum displaced and violet is maximum displaced. So these refracted light rays of different colors shows internal reflection after striking the another edge of the raindrop. These refracted color enter in the eyes of the observer when they refract from the raindrop, as you can see in the figure, and the observer is able to see 7 different colors in form of rainbow. I repeat this again. Sunlight entering into the raindrop. Here refraction will take place and dispersion will take place. Dispersion of white light, and white light disperses into 7 different colors. These 7 colors, when reaches the other edge of the raindrop, they suffers reflection due to critical angle. This critical angle is that angle where the refracted rays makes 90 degree with the normal, and when the incident angle is greater than critical angle, total internal reflection takes place, as in this case of rainbow. जो लाइट है वो उसी मीडियम में वापस रिफ्लेक्ट हो जाएगी, जबकि दोनों मीडियम, जो डेंसर मीडियम है और जिसमें लाइट जानी चाहिए जो रेयरर मीडियम है, दोनों ऑप्टिकल मीडियम्स हैं, ऑप्टिकली ट्रांसपेरेंट मीडियम्स हैं। लाइट इसलिए नहीं जा पाती क्योंकि इंसिडेंस एंगल क्रिटिकल एंगल से बड़ा है। और क्रिटिकल एंगल क्या है? क्रिटिकल एंगल इज दैट एंगल वेयर द रिफ्रैक्टेड रे मेक्स 90 डिग्री एंगल विद नॉर्मल। और जब रिफ्रैक्टेड रे 90 डिग्री एंगल नॉर्मल से बनाएगा तो वो उस पैरेलल पाथ पे ट्रेवल करेगा जिस पाथ पे जो बाउंड्री है दोनों ऑप्टिकल मीडियम्स की, ऑफ मीडियम 1 एंड मीडियम 2। मीडियम 1 इज डेंसर, मीडियम 2 इज रेयर। अब ये सातों कलर की लाइट जब रेन ड्रॉप के एक एज से टकराती हैं तो वापस रिफ्लेक्ट होती हैं रेन ड्रॉप के अंदर ही, वापस पानी की उस बूंद के अंदर ही। और जब ये बूंद के अंदर रिफ्लेक्ट होके दूसरी तरफ टकराती हैं बूंद के सरफेस से, तो ये अगेन रिफ्रैक्ट होती हैं। एज यू कैन सी इन द फिगर, आफ्टर refraction they enter the observer's eye and the observer is able to see the rainbow. फॉर्मेशन ऑफ रेनबो में एक फिनोमिना नहीं है, फिर ध्यान से सुनो। फॉर्मेशन ऑफ रेनबो में सबसे पहले होगा रिफ्रैक्शन, डिस्पर्सन ऑफ लाइट, टोटल इंटरनल रिफ्लेक्शन और फिर से एक बार रिफ्रैक्शन। Got my point? So here are few questions for you. First question of today is, mention the colors for which each letter of the word Vibgyor stands for. I hope you all are able to understand this question and you may answer this question. Now, what is a rainbow? Third question for you, what is dispersion of light? What happens when sunlight passes through a raindrop? Next question, describe the formation of rainbow in the sky with help of a diagram. And the last question is, state the phenomena involved in the formation of rainbow. And we all know in rainbow there are more than one phenomena. Now concluding today's topic, stars seem higher than they actually are, and twinkling of stars is due to atmospheric refraction. Formation of rainbow is due to dispersion of light, total internal reflection and refraction. Example of atmospheric refraction, delay sunset and early sunrise is due to atmospheric refraction. And here is homework for you. You have to solve assignment number 36. Thank you.